So in this lecture, I will discuss the derivation of Bernoulli's equation along a streamline. Good number of students have asked me that this derivation part, even though I have given the guidelines by after solving the Bernoulli's equation for three-dimensional Cartesian coordinates. Based on that request, I decided to really show you the derivation part of Bernoulli's equation considering one-dimensional flow or the flow along a streamline. Let us take straight away into the derivation. So the question is derive Euler's equation and hence Bernoulli's equation considering one-dimensional flow the same thing is called as flow along a streamline. So now if I take it, this is how the streamlines are. If I take the streamline, I take an element in this streamline, a small, we don't call even this as element, you can call this as filament actually, where delta S is the length of the filament and then delta A is the area of the filament, area of the filament. Delta S is the length of the filament. Rho is the mass density of the fluid flowing. Now the flow is taking place along the streamline. So what are the forces that are acting on this? Because Euler's equation is based on the forces actually. The various forces, acting on the fluid element are, number one is the gravity force, which we call it as body force. Second one is pressure force. So now how to analyze? Suppose if I take it, let S be the body force component per unit mass. Per unit mass in the direction of S. Direction of S means this is the direction of S. In the direction of S along the streamline. Right? Now, in such a case, what is the gravity force? Is equal to, or this is also called, I call it as body force component, is equal to S into mass of fluid in the element. So it is equal to S into what is the mass of the element? Delta A, delta S becomes the volume. Volume multiplied by rho. So this is the gravity force component along the basically along the streamline direction. Then next pressure force. Let P be the pressure intensity on the left hand side of the element. Therefore, the pressure intensity on the right hand side of the element is equal to, just go to the figure. So what I mentioned is this is P is the pressure intensity. So what is the pressure intensity on the right hand side? It will be P plus, basically because in the positive direction, P plus dou P by dou S. Dou P by dou S represents what? It is the change in pressure per unit distance. But what is the distance here? Delta S. So P plus dou P by dou S into delta S is on the right hand side. So it is P plus dou P by dou S into delta S. This is the pressure intensity. Therefore, pressure force, pressure force on the left hand side of the element is equal to pressure intensity into area. What is the area? Area is delta A. Right? Similarly, what is the pressure force on the right hand side of element is equal to P plus dou P by dou S into delta S. This is the pressure intensity into delta A. So this. So what is the net pressure force? Net pressure force is equal to P delta A minus P plus dou P by dou S into delta S into delta A. So if P delta A cancel, so it will be minus dou P by dou S into delta S delta A. So now these are the two forces have come to us. One is the gravity force component we have calculated, and the other one is the net pressure force. So the resultant force acting on the element is equal to, what is the resultant force? First body force thing. That means the gravity force component is equal to S into rho into delta A delta S, which we have already done, minus dou P by dou S into delta A delta S. This is the thing, right? Now, according to Newton's second law of motion, Newton's second law of motion, the resultant force acting on the element in the S direction is equal to S direction is equal to, so this is equal to mass into acceleration in the S direction. So what is this? First one is what is the first one? S into rho into delta A delta S minus dou P by dou S into delta A delta S is equal to mass is rho A delta S is the mass into AS. If I see, then naturally you can remove rho A delta S from yeah, if you delta A delta S, if I remove it throughout actually, then basically how it will be, first thing is delta A delta S. So if I remove that, S into rho minus dou P by dou S is equal to rho into AS, right? Then if I divide by rho, S minus 1 by rho dou P by dou S, if I divide by is equal to AS. So what is it? S minus 1 by rho dou P by dou S is equal to AS. This is what actually the Euler's equation along the streamline. That's it. So once Euler's equation is obtained along the streamline, integration of Euler's equation results in Bernoulli's equation. So now to do the integration process, if you see, now I will try to write each of the terms of what is the Euler's equation? S minus 1 by rho dou P by dou S, right, is equal to AS. Now, what is AS is equal to? We know AS is equal to, already we discussed that. It is Vs into dou Vs by dou S plus dou Vs by dou T. So, if I replace that, S minus 1 by rho dou P by dou S is equal to Vs dou Vs by dou S plus dou Vs by dou T. So this is the thing. So this is also with respect to S. This is also with respect to S, but of course this is with respect to T. But now this S also, if I can write actually into a differential form, this also if I write in a differential form, then naturally integration becomes very easy. So that is why what I am doing, I am assuming actually let this sigma be the force potential per unit mass. Per unit mass. So therefore, basically, S is equal to, it is defined as the body force or the gravity force component is defined as it is the negative derivative of the force potential in the what you call which direction, in the same direction. What is this? Yeah, force potential defined such that its negative derivative in S direction gives body force component per unit mass in S direction, because there is only once along the streamline only. So therefore, replacing that there, minus dou force potential by dou S minus 1 by rho dou P by dou S is equal to Vs into dou Vs by dou S plus dou Vs by dou T. Right. Now I will again a little bit minus dou force potential by dou S minus 1 by rho dou p by dou s. This can be written as a half into dou by dou s of Vs square. See, dou by dou s of Vs square is 2 into, right, Vs into dou V by dou s. But what we have is Vs into dou. So that 2 cancellation, to do that cancellation, I have put 1 by 2 plus dou Vs by dou t. This is the first one, right? Now, basically, assuming the flow is steady, flow is steady. If the flow is steady, then dou Vs by dou t is equal to 0. That is first thing. Therefore, the equation is minus dou force potential by dou s minus 1 by rho minus 1 by rho dou p by dou s is equal to half of dou by dou s into Vs square, basically. So now if I basically bring that also onto this side, so it is minus dou force potential by dou s minus 1 by rho dou p by dou s minus half of dou by dou s of Vs square is equal to 0. Now basically if the it is a, yeah, fluid is incompressible. Fluid is incompressible means what? The basic when once I say fluid is incompressible means rho is a constant. Therefore, integrating integrating basically if I take it for before integrating, I will write that also better. First ones to you. That will be very simple for you. Therefore, basically, if I take it dou by dou s of, right? This is force potential. All minus if I remove, it is basically P by rho, right? Plus what is there here? Vs square by 2 is equal to 0. Now you integrate. Integrating plus P by rho plus Vs square by 2 is equal to constant. This is the first. Now we know that actually this force potential, whatever is there. So this force potential is what we have mentioned actually the body, actually the body force or gravity force component is only gravity. Therefore, minus dou psi by dou s is equal to, is equal to what you call it as dou z is equal to minus g. Therefore, is equal to gz plus constant. Substituting it, gz plus p by rho plus vs square by 2 is equal to constant, or p by rho g plus vs square by 2g plus z is equal to constant. So this is along the streamline. This is the Bernoulli's equation along a streamline. Bernoulli's equation along a streamline. In case of streamline flow, Bernoulli's equation is applicable even if flow is rotational. So that we should. The conclusion is, what is the conclusion actually of this? If flow is steady, irrotational, incompressible, the sum of pressure head, velocity head, datum head is constant. Already assumptions I mentioned number of times. Assumptions in Bernoulli's equation. One is fluid is ideal. First one is that it is applicable to ideal fluid flow. Fluid is incompressible. Third one is flow is steady. Last one, flow is irrotational. So these are the things. And if you want to apply Bernoulli's equation between 2 points, it is P1 by gamma plus V1 squared by 2G plus Z1 is equal to P2 by gamma plus V2 squared by 2G plus Z2. And if you want to apply, if you wish to apply Bernoulli's equation for real fluids, real fluids, then P1 by gamma plus V1 squared by 2G plus Z1 is equal to P2 by gamma plus V2 squared by 2G plus Z2 plus head loss. This is extra. So this you should remember, where HL is called as head loss. So here I will stop this equation. Please remember that the continuity equation, Bernoulli's equation, impulse momentum equation are the fundamental equations of fluid mechanics. So please thoroughly work on the continuity equation, Bernoulli's equation, and of course impulse momentum equation, the statement and its applications. These are all very, very important actually in this entire the second unit where we are dealing with fluid kinematics and fluid dynamics.
Like, share, and subscribe. Hit the bell icon for more updates.